Hello and welcome to today's presentation. Today we will be going over an introduction to ROS2. So here are the topics for today. Alright, first off, what is ROS? So ROS is the Robot Operating System. And pretty much what this is, it's a set of software libraries and tools for building robot applications. So the major revision of ROS is ROS2, and that's the current major version of ROS. There are many different distributions of ROS and ROS2, and each new distribution contains updates and changes to the major version. Also, a fun fact, the mascots of ROS are turtles. So in the name of each distribution, there's actually a name of a turtle, such as a hawksbill turtle, Irwini turtle, and Ridley turtle. And then in the bottom left, you can see the ROS logo, and you can see the three distributions on the right. These distributions are for ROS2. So why use ROS2? Our robotics team is using ROS2 as a framework for our code to be able to communicate between devices and handle sensor data. So what does ROS2 do for you? It actually does intra-process communication. It handles communication, and it handles communication over a network. And so we're also using ROS2 because it's open source, it's an industry standard, it's easy to learn, and it's a major upgrade from ROS1. And also ROS1 will be at its end of life soon. And so that's also a reason why we're using ROS2. So which distribution of ROS2 are we using? So last year, our team was using ROS2 Humble, and the year prior, we were using ROS2 Foxy. So this year, a new distribution came out called ROS2 Iron, but we are going to stick with ROS2 Humble, as ROS2 Humble seems to be the LTS of ROS2 right now. Or an LTS, or a long-term support build. And ROS2 Iron, you can see the end of life date only being about a year or so after its release date, while the ROS2 Humble distribution end of life date is in 2027. So let's go over some basic concepts. So first of all, what is the ROS graph? So the ROS graph is a network of nodes in a ROS system and the connections between them by which they communicate. So what is a node? A node is the unit of computation in a ROS graph. Nodes have the capability to communicate across multiple programs and multiple devices, and even over a network. Each node can send and receive data from other nodes via topics, services, actions, or parameters. So in the bottom right here, you can see nodes, these nodes could either be in the same program or separate programs. It could be on the same computer or a separate computer, but they would still be able to communicate to each other. And so also make note that each node should have a single modular purpose. So for example, one node may be for controlling a motor driver, another node may be for publishing sensor data. And as a whole, this image shows an example of a ROS graph. So ROS2 is something that is called a strongly typed anonymous publish subscribe system. So what does this mean? Let's go through the different words in this phrase. So publisher is a producer of data. A subscriber is a consumer of data. In this context, anonymous means that you can swap out publishers and subscribers at will without affecting the system. And strongly typed means that ROS2 uses a message type for communication between nodes. So just like C languages, where they are also, most of them, or at least that I know of, are strongly typed, where you have to specify integer, array, string, character, etc. ROS2 is just like that. So to be able to communicate between nodes, the nodes need to have the same type of information, and the type needs to be specified. And also, just a note, you can actually create your own custom types as well. So interfaces. What are interfaces? Interfaces are the methods in which communication is done between nodes. So there are three main types of interfaces: topics, services, and actions. And you can see images from left to right showing a graphical representation of each. So first of all, let's go ahead and talk about topics. So a topic is a common name that lets publishers and subscribers find each other. Topics should be used for continuous data streams, such as sensors and robot states. So in this graph right here, you can see there are two nodes. One node has a publisher, one node has a subscriber, and they're communicating over a common topic name. And an example of this, which we'll see in a second actually, will show a usage of a constant data stream. So right here's an example. Let's say we have two Raspberry Pi computers. One's hooked up to a display and one's hooked up to a camera. And let's say that they are on the same network so that they can communicate to each other. So the publisher, which is the object that produces data, would be on the Raspberry Pi containing the camera. So the script or the program on the Pi would run. It would create a node and a publisher, and inside of that node would then read images from the camera and publish that data over the topic, and then over the topic name through the network and to the Raspberry Pi number 2, and the program running on Raspberry Pi number 2 would have its own node and a subscriber, which again is a consumer of data. And because it's listening to this common name, this common topic name, it's able to receive the data and display it onto the monitor. And so we actually have an example of this right here that I previously recorded. So let's get that over here. So pretty much I had set up a stereo camera with a Raspberry Pi, as you can see here, and I just have it plugged into the wall. And it's actually connected to my home Wi-Fi network. And if we skip ahead a little bit, you'll see where the other side, oops, there we go. So this is the other side. So we see the camera, the Raspberry Pi, and it's facing my backyard. And if we skip ahead a little bit, I SSH into the Pi, so camera.RPI, RPI. And I have my laptop here, which is upstairs. And I go ahead and run the publisher on the Pi, which publishes the camera data. and I run the subscriber on my laptop, which receives the camera data, and I end up being able to see through the camera from my laptop. So you can see in the bottom right here, the Pi is publishing camera images or frames, and then we can see this window where I'm actually receiving it. And you can see like the leaves moving from the trees and stuff. So let's go ahead and close this. Alrighty, so let's go ahead and talk about RPCs, or a remote procedure call. So what is a remote procedure call? An RPC is when a computer program causes a procedure or function to execute in a different address space. So by different address space, this could mean on a different computer over a shared network, or even across two separate programs. So for example, if you had your computer and another computer, you'd be able to call a function on another computer. If you had two separate programs, you'd be able to call a function from one program that would communicate to the other program and call the function there. So RPCs are actually written as if they were a local function call. So just like you write a function in your local program, that's how you would write it to call a remote function. And this pretty much means that, yeah, exactly. The programmer can essentially write the same code, whether the function is called inside the local program or remotely. And in the bottom right, you can see the basic operation of an RPC. So pretty much you have the client right here, which calls the P function, which contains data for X, Y, and Z. The server receives that and returns a value to the P function, which the client then receives. And this is over a network. Actually, let's talk about an example of this. So for example, in video games, in let's say a multiplayer video game, your computer and the server would be calling RPC codes. So let's say you go ahead and let's say you're in a room and there's a door, and when you go to open that door, let's say you press E on the keyboard, it actually sends an RPC to the server asking, hey, can I open this door? And if the server says, yes, you can open this door, the server will open it, and then the server will say, hey, let's update the visualization of this door and the physics of this door on your computer so that it's accurate to the server. So then the door will be shown as open on your computer. Let's now talk about services. So this is another type of interface, which is, again, a method of communication between nodes. The first one was topics. So services. A service is pretty much an RPC. So a node can make a remote procedure call to another node, which will do a computation and return a result. Services are identified by a service name. So this is similar to a topic name, but it's in a different namespace for services. And also a note, services are expected to return quickly, as the client is generally waiting on the results. Services should never be used for longer running processes. So a service consists of two parts, a service server and a service client. So what is a service server? A service server pretty much accepts a remote, it accepts an RPC, it accepts a remote procedure request and performs some computation on it, then returns a result to the service client. Now the service client is is the one who requests a remote service server to perform a computation on its behalf. So the service client pretty much sends an RPC to the server, and then the server returns a result to the client. And so we have a basic example of this right here, where we have a service server and a service client in this graph, and they're talking over a service, which a service, again, is defined as having a request and a response. So an example of this, let's say the client requests an addition of integers and sends two integers. The request goes through the interface, through the integer addition service interface. And again, this interface is here so that both nodes understand what they're receiving and what they're sending. So the server receives the integer addition request, the server adds the integers and returns the result as a response over the service interface back to the client, which the client then receives the addition results. Now let's talk about our third interface, which is actions. So an action is a long-running RPC, but this is a long-running RPC that also has feedback and the ability to cancel or preempt the goal. So cancel in this context means stop processing currently active goals, and preempt in this context means to stop processing current goals in favor of new goals. So actions are identified by an action name, and again, similar to services and topics, they're similar to services and topic names, but again are in a different namespace for communication. And actions are expected to be long-running procedures. So if you need a short-term RPC, use a service. If you need a long-term RPC, use an action. And also actions are actually made up of services and topics, and we'll see an image of that in a second. So to continue, an action consists of two parts, an action server and an action client. So the action server accepts a remote procedure request and performs some procedure on it, and it's also responsible for sending out feedback as the action progresses. And the action server should react to cancellation and preemption requests. Now the action client is one who requests a remote action server to perform a procedure on its behalf, and it receives feedback about the operation from the action server and is able to cancel or preempt the operation. So here's an example of an action server and action client. So let's say that you have a robot that autonomously drives to waypoints where the client is run by the user. So this would be the person at the base station controlling it, and the server runs on the robot. So let's say the client sends a waypoint goal to the server. So we have our action client here, and we have our goal service client, which is going to be sending a message through the goal service interface to the action server, which receives the goal. The server then decides to accept the goal or reject the goal and returns its choice to the client. So in this case, let's say that it accepts the goal. And so once it goes here, the response is, I accept this. And then the client now knows that the goal has been accepted. Then the client requests the robot to begin traveling to the given waypoint. And the server receives this request and begins travel. So yeah, the request here was the goal. But oh, no, the request is right here. So the result service client sends the request, the action server receives it, and later on it will be returning a result, but after the server completes the operation. And so after the result service client sends the request and the server receives it, and it had already accepted the goal, the server does operations on that request, and during those operations it will be constantly sending and publishing feedback to the action client. So for example, let's say the robot is sending its distance to the waypoint constantly back to the client so that the client knows how far it currently is from its waypoint. And then once the robot successfully reaches the waypoint, it will return a result of success as a response to the client. So now the client knows that the robot successfully made it. It can also return a response as an abort. So let's say the robot couldn't get to its waypoint, it may abort, or it can be also canceled by the client and say, yes, I've successfully canceled the operation. So it's definitely a little more complex than a service. All right, so let's move on to parameters. So parameters are used to configure nodes at startup or during runtime. And this is done without changing the code. This is able to be done without changing the code. So the lifetime of a parameter is tied to the lifetime of the node. So when the node starts up, it'll have the information about the parameters. And then once the node dies, the node will no longer have that information. When the node starts, it actually needs to load in that information. So parameters are associated with individual nodes. So we have an example here, example usage of parameters. So on the right here, we have a node that's connected to a camera. So imagine this is running inside of the Raspberry Pi, and it has a publisher. And let's say when we start up the node, we want the camera FPS to be 30 frames per second, and we want the resolution to be 1920 by 1080. We can specify that as a parameter for this node on startup. But also, we can specify values if we wanted to actually during runtime as well. And so we'll see that over here, where we actually have the node subscribing to the images, and you would be able to specify parameters for this node. So for example, if you wanted to add a filter at runtime, you could. So image filter equals grayscale, so that it's black and white. Or if you wanted to change the brightness or saturation, you could, and then display it on a monitor. So this would be an example of post-processing, and this example right here would be an example of camera configuration. So now let's go ahead and talk about launch files. So a ROS2 system will typically consist of many nodes. So using a launch configuration makes it easy to launch multiple nodes at once. The launch configuration of a ROS2 system includes what nodes to run, where to run them, and what arguments to pass to them. So the description of a launch configuration is all specified inside a launch file. And we'll have an example of that right here. So example usage of a launch file. So pretty much you can see instead of instead of having to by hand specify the parameters for each node, you can have one file and specify the parameters that you need. So for example, this file here, this launch file, we have camera frames per second set at 60, resolution 1280 by 720, and brightness 50. And when you go ahead and run the launch file, it will actually boot up a node with a subscriber, which has the initial config of none for its image filter. It doesn't have a brightness value yet, and it has a saturation of 50, but these values will be overridden by this launch file, overridden or set. And then the launch file will also run a node that contains a publisher, which is connected to the camera. And right here you specify the resolution and camera FPS, and these values will be automatically set by the launch file. And then here are some resources as well. And then that's about it. Thank you.